All right, so we're going to finish up by looking at the second part of law of sine. So it's still the same section we did yesterday. But we're going to look at the case where we could end up with the two solution and a no solution. All right, so just a reminder about what the law of sines is. It's three different fractions. Sine of alpha over A equals sine beta over B, which equals sine gamma over C. You only use 2 out of 3 of these fractions at a time. Either the first two, last two, or the first one and the last one. And remember, there's 3 types of triangles that fall under law of sines. Does anybody remember one of the 3 types we talked about yesterday? These have 3 letters in them. Yeah. Angle side angle, which is not one we're going to talk about today because that only has one solution. Yep. Yep. Angle angle side. Again, another one we are not going to do today because it only has the one solution. And what's the third case? Yep.
Side angle angle.
Side angle angle. That's this one.
Oh, no, yeah, it's angle side side.
Yes, but I'm not going to write it that way.
Yeah,
I'm going to write it that way. So, side angle. And this is the case where you have to check for 0, 1, or 2 solutions. Tomorrow, we're going to talk about law of cosines. And I'm going to have 2 more types written down right there. And I'll tell you what those are tomorrow. All right, let's look at side angle. Okay, so here's our problem. So even without sketching the triangle, which we'll sketch it, but even without sketching it, how can I tell by looking at the table that this is a law of sines problem?
You have a full row.
Yep, we have a full row. Okay, if you've got a full row, it's definitely law of sines. If you forget how to tell on the test, but you remember these are the 3 types you can do with law of sines, we can figure it out that way too. Draw a picture, which again, not to scale. Let's just draw a picture. So A is 6. Alpha always has to go across from it. B is 8. Beta goes across from that. And then C goes across from gamma. If you look at the information you're given here, that's an angle, a side, and a side. Whenever you have 2 sides and an angle, and the angle isn't between the 2 sides, that's that type. 2 sides, but the angle is not between them. When I mean between them, that's the angle between the 2 sides, gamma. It's where the sides meet. If we knew that angle, that would be side angle side. SAS. That's going to be something we talk about here. SAS would not work with this law because you'd have 2 sides and then you'd have an angle. So you'd have 3 partial rows. You can't solve law of sines with 3 partial rows. You need 1 full row. All right, so what do we have to find first here? Beta. So that's the box we're going to focus on first. Then what box will we focus on second? Right. Once we have 2 of the angles, we can add them up and get the third. And then we can finish the problem by getting C. Now, when I make boxes, I would leave, leave enough space in that box. Make it plenty big. Let's find beta. Okay, so set up kind of the format of how all these problems look. Sine. And what's going to go on the left side? Yeah. Keep going.
No.
Keep going.
Degrees? Percent, like the whole thing?
The whole thing.
35 over 6.
35 degrees over 6. So sine 35 over 6. And then on the right, sine beta over 8. And again, we don't even really need to cross multiply. We just need to get sine beta by itself. So what could I do on both sides to make that happen? Just multiply both sides by 8. Times 8. Times 8. And I get 8 sine 35 over 6 equals sine beta. And you can reduce 8 over 6 to 4 over 3. But honestly, whether I press an 8 and a 6 or a 4 and a 3 on the calculator, what difference does that really make? So I would just leave it as 8 over 6. Okay, well, that's sine beta. We want to get rid of sine, so we have beta by itself. So how can we cancel out sine? Yep. Inverse. We're going to take the inverse sine. And we're going to plug everything on the left into inverse sine. And everything on the right. On the right, when you plug the sine into the inverse sine, again, it's like squaring and square rooting. It cancels out. So now we need to type that in. At this step, one of two things will happen. You're either going to get a no solution, which means you did something wrong, or the problem really is no solution. Or we're going to get an answer. And if we get one, then we have to check for 2. Okay, so inverse sine of 8 sine 35 divided by 6. That's how you type it. So just make sure you're watching those parentheses. We get 49.886. So this is not a no solution problem. I just got a solution. So 49.886. Okay. Now, what do I do with that number to find the potential second number? Yep.
Subtract from 180.
Right, we're going to subtract that from 180. So 180. I can just do minus the last answer I had. And I get 130.114. So you found what you think the second answer could be by subtracting the one you got from 180. Now you have to see if that answer fits. And we say, yeah, add 35 to it. And see if you're still under what?
180.
Still going to be under 180. What's 35 plus 130?
165.
Yeah, so we get 165.114. Is that under 180?
Yep.
Yep. So what that means is this is a second answer to beta. So what we're going to do now is we're going to call the first answer beta 1. We're going to call the second answer beta 2. And now if beta has 2 answers, then everything we have to find has 2 answers. The betas, the gammas, and the c's. So essentially what we're doing right now is we are solving 2 totally different problems. We're just doing it all in the same table. You could make separate tables if you want, but I tend to just keep it all together. And if you want to kind of visualize what the 2 problems are, let me show you. We'll call it like the red problem and the green problem. The red problem has this angle, and that angle. The green problem has this angle, that angle, and that angle. And if you look, you're like, well, you used alpha twice. You're right, I did. Alpha is in both problems. The 1s are all in the same problem, and the 2s are all in the same problem. So if we do that again, A is in the red problem, B is part of the red problem, and C1 are the 3 sides in the red problem. A is in the green problem, B is in the green problem, and C2 is in the green problem. So if you look at that, you should see 3 red sides, 3 green sides, 3 red angles, 3 green angles. And there is some shared pieces of information. 3 pieces are shared. All right, so now we've got beta 1 and beta 2. Before we keep going, any question on how we got beta 1 and beta 2? All right, let's do gamma 1. What angles am I going to add together and subtract from 180 to get gamma 1? 35 and 49. Those are the 2 angles that are going to be added together and then subtracted from 180. So 35 plus 49.886. That gives me 84.886. Those are the first 2 red angles. Now subtract that from 180. So gamma 1 is 95.114. Now, you could at this point go do C1. Okay, but while I'm doing the angles, I like to just finish those off first. Okay. Can somebody else tell me how are we going to get gamma 2? What are the angles involved with finding that? 35 and 130.114. We're going to add those together, and then we're going to subtract from 180. What's 35 and 130.114? We actually already added that up. What is it? What is it? 165. So 180 minus 165.114. So gamma 2 is 14.886. Okay, so now we've done all the angles. We need to find the sides. C1 is, we're calling that the red problem. So to solve C1, we need a red row that's complete. I see 2 rows in that table that are red rows. A and alpha, B, beta 1. That's a red row. Which row should we use?
The top row.
The top row. Why not the B and beta 1?
Because the top row was given.
Yeah, the top row was given. So we're going to set that up, sine 35 over 6. Same way we did right up above. And Grady, to find C1, what would go on the other side?
Gamma 1.
Yep, tell me the whole thing I would put right here.
That would be sin gamma 1 over C1.
Yep, 95.114 for gamma 1 and over C1. Alright, so that's how we set it up to do C1. Okay, let's set it up for C2. Okay, to find C2, C2 is part of the green problem. Well, I need a green row that's full. What row there has everything in it and would be considered part of the green problem? So again, sine 35 over 6. Equals, and Cameron, if I want to find C2, what's going to go on the other side?
Sine 14 by 8.
Divided by? We're not finding, we already used gamma up here.
Oh, let's see.
C2, because that's what we're finding C2. All right, now cross multiply on both of them. The only thing that's going to be different is you're going to change 95 to 14 when you do the next calculation. But we got to type it in the first time. So it's a 6. So 6 sine 95, 95.114. Close your parenthesis because you're done with the sign. And now do this one, divided by sine 35. Okay, so there's our answer for C1. Now let's type in C2 at the same time. This time it's going to be 14.886. And maybe it's quicker just to retype the whole thing. I don't know. I still think that's a little quicker. Divided by sine 35. Okay, so that is C1. That is C2. Now I'll write those up above. So 10.419 and 2.687. So with this kind of problem, I don't really think it's not a harder problem, it's a longer problem. You have to do exactly the same thing twice. So it has double the amount of answers, but it would count as 6 different answers on the test. So it would also be worth more points. Any questions on that one? That's the 2 solution. All right, let's try. That was just a chart. Let's try this one. Okay, I'm not even going to draw a diagram this time. Without the diagram, can someone remind me again, how do I know that it's law of science?
There's a full row.
There's a full row. Bottom row is full. And the way we know that this is the worst case for law of science, or potentially the worst case, which I think the 2 solution one, I call that the worst. The way you know that is you have a middle row, and there's no way to get anything in that row directly. Okay, so what does that mean that I'm pretty much forced to have to figure out first? Yep.
Alpha.
Yeah, I've got to do alpha first. Okay, so let's set it up. So we're using the top row and the bottom row. Forget about the middle row. There's nothing in it that can help you. So don't use the middle. What can I put on the left-hand side? Yeah.
Oh, sine 50 over 1.
Yep. Sine 50, and this time it's just over 1. So dividing by 1 doesn't even change it. So sine 50 over 1. And what would go on the right? Yeah.
Sine alpha over 2.
Good. Sine alpha over 2. So just multiply each side by 2. And that'll get sine alpha by itself. Times 2. Times 2. 2. Sine 50 equals sine alpha. And now we've been at this step a couple times where we got a variable that's part of a trig function. We need to get it so it's not in that trig function. How am I going to get rid of sine? Yep.
The inverse
Yep, I'm going to take the inverse
of sine.
of sine. Because tomorrow when we learn the law of cosine, we're going to have to do the inverse of cosine. Okay, but today it's inverse sine. And inverse sine. When you take the sine of the inverse sine, they cancel each other out. And now we get this. Second, inverse sine of 2 sine 50. And when we hit enter, we get a domain error. Well, just think about that for a second. Look at this picture, not that picture. When you look at a picture of sine, we did that last week. What's the highest and the lowest that it goes? It goes between 1 and -1. Type in 2 sine 50 and see what that comes out to. 2 sine 50. I must have messed something up. 2 sine, oh, I got an extra part to see. 2 sine 50 is 1.53. Is 1.53 between -1 and 1? Anything, Sam?
No.
No. So, mark what 1.53 is on this graph. 1.53. Now, tell me where that blue line and the red wave cross each other. Never. That's why there's no solution. You're basically trying to, when you type that into the calculator, you're asking it to figure out where these two things cross. This number is too high. It's above the graph, which means it's never going to cross it. So that means there is no solution for alpha. Now, if I had gotten an answer for alpha, how would I use that to now get beta?
Would have added it with 53.
Yeah, I would have added it with 50 and then just subtracted it from 180. But the problem is, because I wasn't able to get alpha, I'm also not able to get beta. Right, and if I can't find an angle, then I cannot figure out the side that's across from it either, because I need a partial row. And right now, this is an empty row. And it's going to stay empty because I can't get beta, because I couldn't get alpha. So this also has no solution. So that's an example of the no solution case. And what that would mean visually is if you tried to draw this triangle, you wouldn't be able to make it. You'd have something that looks kind of like this. Let's see, this side would be like 2 units long. That would be A, over there. C would be 1 unit long. That would be like up here. And gamma is 50 degrees. So I'd have to draw and make this angle right here 50 degrees. Now you can't change this angle, which means you can't bring that side up. This is B. We weren't given B, so you can make it as long or as short as you want. You can do whatever you want with B lengthwise, but you can't tilt it because that would change the angle, and that was given. The other thing you can do is, we don't know the angle for beta. This would be beta right here. You can make that angle anything you want. So you can take side C and you can swing it however you want, but you can't change the length of it. It has to stay 1. So no matter how long or short you make B, and no matter how you change side C, will these two things ever connect? No. It's impossible to make a triangle with that information. And that's why. Okay, any question on it? So in terms of the case, I think that's the quickest one, because you realize pretty much right after the first step, trying to solve the first thing, then it's no solution and done.
Will it always be the first step you find no solution?
Yeah, because yes. You're always going to know right at the first step. Because if you would have gotten a number at the first step, then that means everything has a number. And then you have to check for the second number. But remember, the only case that you have to do that with is side-side angle. You don't have to do it with the other two cases we learned. You don't have to do it with the two cases we're going to learn tomorrow. These 4 cases all have one solution all the time. The bottom one is when you have 0, 1, or 2. And you can't mix up when you use these laws. I know we haven't learned law of cosines yet, but you cannot use law of cosines on a law of sines problem. It will not work. You won't. Won't be able to. Okay, let's see. Do we want to do that one or that one? Let's do this one. Okay, so this will be our word problem. Remember what I told you about word problems. We have a word problem that's drawing a triangle to measure the height of something or the distance between 2 points on a map. You can't get 2 answers. It doesn't make sense for like the height of a mountain to be this tall or this tall. It's only one number. So we're only going to get one answer in this type of problem. So once we set it up, this will be kind of a review of yesterday. Well, before I cover it, this one's about the height of a mountain. The other one is about it's like a Coast Guard problem, like locating where a boat is. Does anybody have a preference which one we do? The height of the mountain or the Coast Guard one? Which one? No? Anyway. Okay. I guess we can do this one. So the way that this is going to work, something practical, you can actually do this. To measure the height of the mountain, we don't have to know how far away we are from the mountain. All we have to do is stand in one spot, take a measurement. I'll explain what that measurement is. And then back up a known distance, 200 feet, 300 feet. Get in your car and just measure how far back you drive. But back up straight a certain distance and take a measurement again. And those 2 measurements will tell you how tall the mountain is. All right, so what do you have to measure? Well, first of all, whoever does this measurement, they're going to do the 2 measurements 900 meters apart. It's not important you have to know how far apart you are from the first time you measured it and the second time. But it doesn't have to be 900. It could be 600. It could be 1,000. It could be anything. But the point is, you got to take 2 measurements. And what you need to measure each time is what's called the angle of elevation. The angle of elevation is, imagine you had like a really powerful laser pointer on the ground, and you tilted it so that it pointed exactly at your object. That's called the angle of elevation. Like if you were aiming something right at the top of the mountain. So when the surveyor takes the first measurement, they get an angle of elevation of 47 degrees. So think of it as the angle you'd have to look at to make your eye perfectly focused on the top of the mountain. And then when the surveyor backs up 900 meters and measures the angle again, they get 35 degrees. You would expect the angle to go down because the further away you get from something, the less steep you'd have to look at it. Think of like me looking at a light. If I'm right underneath it, I'm very close to it, I have to look up at a very steep angle to see it. But if I could back up like 100 feet, I wouldn't have to look up as steep because I would be further away from it. So it's the same idea. So the important thing here is distance and the 2 angles. Those are the 3 numbers that we have. Now the device you could use for measuring an angle like that is called a transit. Probably maybe you've never used one if you're not, kind of shop that would. I think house carpentry has transits, and it's a device you can use for for measuring things, usually outside. Now, technically, we would have to take into account the height of the transit, because when you point the transit at the mountain, it's usually on a tripod. Sometimes you see people like on the side of the road, like they have a tripod set up. Anyone ever see those people measuring things? Well, the tripod has height to it. Usually it's like 5 or 6 feet tall, and then they're looking through it. We're just going to pretend that the transit is laying on the ground. So we're not going to take into account that 5 feet or 6 feet. That's okay. All right, so a lot of information there. When you have a problem like this, what do you think the best thing to try to do to make all this information more understandable is? Yeah, we need to make a diagram. Absolutely. And don't worry about making a triangle. That's not really the goal. The goal is to draw the objects in that problem. If you draw the objects correctly, a triangle will happen automatically. So, what are some objects in this word problem that are very important?
47 degrees.
Well, that's going to be a measurement of something. But for now, I'm just thinking like, if I was going to use like clip art and like draw a picture of this whole scene, what's some things I need to put in it?
First observation.
Okay, so we're going to mark the 2 observation points. Those are important. So we can have like a little person in 2 different places. What else do I need? The what? Top of what? The mountain. I need a mountain. So I'm going to have 2 people. I'm going to have a mountain. And there's one more very important thing I need. I need the ground. Right? So we're not going to draw this real fancy, but we're just going to draw in the ground. Here's the ground. Here's our mountain. And we've got somebody who's going to measure something from 2 different points on this side of the mountain. Now you could do it on either side of the mountain. I do it this way. I'm going to measure something here, and then they're going to measure something here. What do we know about the distance from the 2 measurements they take? That's how much? That's 900 meters. And each time you're measuring an angle of elevation, that's the angle from the ground to the object you're measuring. It's called angle of elevation. So let's draw a dotted line that represents like a laser being pointed from the ground up to the peak. And then doing the exact same thing again. The first time that the surveyor does it, what does it say that the angle of elevation is? How much? 47. That's the angle between the ground and how the laser is pointing. And what about the second time they pointed at the mountain? 35? Okay, that's that. So the goal is to measure, I mean, they didn't kind of explicitly ask it, but they said it right here. Measure the height of the mountain. So the height of the mountain is not like if you were hiking or climbing up it. It's like a line straight down. That's the height of the mountain. So that is what we want to know. And I'll make that green so we remember that that's what we want to focus on. And that's our height. And height is drawn perpendicular. That's straight. All right, so we've got a couple different triangles here. Let's look at this one first. What I'm going to do is I'm just going to trace over this. I'm going to pull that triangle down so I can focus on just looking at that. Okay. So that's my height, which that's the whole goal of the problem. Just find h. This is 47. Now, I could find this other angle in the triangle because I know 2 out of 3 of them, and I know they have to add up to 180. But that's not what they're asking. They want the height. Do I have enough information in this triangle to find the height? No? Why? What am I missing that I would need? You need a side, yes. You cannot solve a triangle if you don't know any of the sides. That's impossible. So I can't really do anything with this right now. I'm going to come back to it, and hopefully eventually I can solve for the height. But I can't solve for the height without figuring out one of the sides in that triangle first. Before we keep going, is there any question why you can't solve for the height? All right, so let's look at a different triangle. Let's look at this one. Right there. What do you notice about these two triangles in terms of like anything they have in common?
Put them together, they make a big one.
If you put them together, they make a big triangle? Yeah, they make a bigger triangle. All right. What else do you notice about something that they share? Yeah?
The bottom leg is 9 inches.
Yeah, okay, so we know that. But there's something in this triangle that's the same as that one.
That angle.
I'll do the angle opposite of 47. It'd be 180 minus 47.
Okay, so we can figure out this angle because if this is 47, then this one inside is 180 minus 47. So, yep, we could write that down, which is, what is that? 180 minus 47. Okay, so that's 133. Okay, is there anything else I know in this triangle on the left?
35 degrees.
Yep, I know the 35 degrees. Now we've got some information. Angle, side, angle. ASA. ASA. So now we have a triangle that we can figure out something. Now, this triangle is not going to give me the answer to the question, but it's going to give me something I can use to get the answer. What do you think I would ultimately want to figure out in this triangle? Because it would actually give me something in this triangle.
There's one side, this is side,
Yeah, which side?
the right side.
Yeah, you would want to find this because it's the same as that. Those two things are the same. So if you can figure out this side, then you're going to have a piece of information in this triangle, which we can then use to find the height. Okay, so let's see if we can find that side in red. Well, to do law of sines, you need an angle, and you need the side across from it. I don't see an angle in this picture and the side across from it that I know did what's labeled. Does anyone see what we could do with that triangle on the left?
We can add the 35 and 133
Okay, so we can add those together, yeah.
and subtract it from 180.
Right, and then subtract that from 180, and what does that give me?
Gives you the angle across from the one side.
Gives me the angle across from the side that I know, and there's my full row if I was making a table. So that's when you subtract from 180, that's going to be 12. So now you know this angle right there is 12. So let's set up our law of sines. I don't know, we could just call that side A. And I'll write down find A. Okay, what would go on the left side if I fill in the full row? Sine of what over what? Yeah, it doesn't even matter. Is that A or B or C or alpha or that? I don't know. I have no idea. But I know that's the angle, and that's what's across. So just fill that in. Sine of 12 over 900 equals. And what's going to go on the other side if I'm trying to find A? Sine 35 over A. Now, why even find A again? Why not find this side up here? Yeah, A is the side that they share. That's this side right here. So once we know that, then we can work with that right triangle. That's the easy part. Finding A, that's the harder part. Cross multiply. And see what you get. So 900 sine 35. Sine 35. And Gavin, what am I going to divide by?
Which side would it be? It would be sine 12.
Yep. I'm going to divide by sine 12, and that's going to get A by itself. Okay, so we know A is 2,482. Let's just say 0.9. All right, we're just going to round it. 2482.9. So A is 2482.9. Looking at that right triangle, I called it A in the triangle on the left, but it's really what in the triangle on the right?
C.
It's like the C, which is the hypotenuse. So I guess I could have used C, but that's fine. This is 2482.9. Now you've got a right triangle. You don't need to use law of sines to solve a right triangle. Look at your angle and figure out the position of these two sides. And then we'll have a trig function. What position is side H relative to 47?
Opposite.
Opposite. What position is the 2482? Hypotenuse. So this isn't law of sines at all now. We don't need it. What trig function, sine, cosine, or tangent, has opposite and hypotenuse in it? Sine. Just a coincidence we're doing law of sines and it ended up being sine. It could have ended up being tangent, but it didn't. Okay, so sine of my angle equals opposite over hypotenuse. Fiorella, what's my angle?
47.
47. And Sam, what's my opposite?
H.
H. And Ryan, what's my hypotenuse?
2,482.9.
2482.9. And my last step is now to get the H by itself. So how about 1? How do I get H by itself there? So I'm looking for either like an add, subtract, multiply, or divide.
Oh, multiply.
Yep, you multiply.
Multiply 2,482.9.
Okay, yes, multiply 2482.9 on both sides. Oh, it does that. So 2482.9 times sine 47, and that's my height. Let's see what the height is. So 2482.9 times sine 47. So the height of the mountain is 1,815.9 meters. Rough. So 1815.9. So the tough thing about that is you couldn't find what you wanted directly. You had to find something else first to then be able to find what you wanted. But the key is really making a diagram and looking for the two triangles when you got it. Okay. Any questions on that? So that finishes up the law of signs. So that's the homework for tonight. It's about the same number of questions as last night. Maybe a couple less. But 29 to 35 odd, 39 and 43. It is possible you get no solution. So don't think if you get a no solution, you're doing it wrong. You might not. And then tomorrow we will finish everything for this week, which is law of cosines. Okay.